This lecture is about sound wave interference, specifically interference that occurs between two sound waves broadcast from two separate speakers or sound sources, each broadcasting exactly the same way at the same time with the same precise wavelength lambda. Under certain conditions, the maxima of one wave will overlap a maximum of the second wave, and the peaks likewise at the same time will line up. So there will be a doubling of the amplitude, a doubling of the effect, a louder sound will have occurred. We speak of this situation as one of constructive interference. At the end of this brief lecture, we'll discuss the opposite sort of interference, destructive interference. What are the conditions that have to be satisfied in order that two sound waves interfere constructively, giving a louder sound? I'll illustrate that here. I show a speaker labeled number 1, broadcasting sound wave at a wavelength lambda. A second speaker is doing exactly the same thing at the same time with the same wavelength. Not shown down the line here is an ear or some sort of sound detector which receives both sound waves. Notice that this speaker is closer to this imaginary speaker or imaginary ear, I meant to say, than is this one. It happens that you're to believe that this speaker is a distance twice lambda closer to that imagined listener, closer than this one. In such a case, the maximum or maxima of the second source's sound waves line up peak to peak, valley to valley, peak to peak, valley to valley. Both are lined up in a constructive manner, doubling the effect, making louder sound. I show down here the sum of the two waves that are overlapped. Peak and peak gives a larger peak, valley and valley gives a deeper valley, and so on. The general condition that has to be satisfied in order that constructive interference occurs, I'll describe now. Let L1 be the length of the path, the distance followed from speaker 1 to the imagined sound detector. Let L2 be the shorter of the two distances, in this case the distance between speaker 2 and that imagined listener. In order for constructive interference to occur generally, not just for this particular case, the path length difference, the larger distance traveled minus the smaller distance traveled, must be an integer multiple of lambda. In this case, the integer multiple was 2. And so L1 minus L2 is 0 or lambda or 2 lambda, 3 lambda, 4, 5, or 6, whatever. Multiple different conditions will give rise to a constructive interference. A more compact way of writing this sequence of allowed path differences is shown here. The path length difference can be n times lambda, where n is 0 or 1 or 2 and so on. So far so good? You with me? All right then. What about destructive interference? Destructive interference occurs when, let's say at the listener's ear, wherever a peak, a maximum from one wave is presented at the eardrum, a valley, a minimum from the other wave appears there simultaneously. So the net effect is a zeroing at that place, and what the ear detects at that place is what is heard when nobody is speaking, no sound is being broadcast. The pressure at that place where complete cancellation occurs is just atmospheric pressure, P naught. Well, in order that destructive interference occurs, and I don't illustrate it with a diagram on the whiteboard, the path length difference, instead of being 0 or 1 or 2 or 3 times lambda, it's 1/2 lambda, 1.5 lambda, 2.5, 3.5, 4.5, 5.5, and so on. The more compact way of writing this condition is shown in the parentheses. Twice n plus 1, all divided by 2, then times lambda, where n can equal 0 or 1 or 2. Let's just check a couple of these to see if this equation is correct. What if we want to talk about the n equal to 0 condition? In such a case, n is 0, twice n is still 0 with the 1 left over divided by 2, 1/2 of lambda, that's this condition. If n is 1, 2 times 1 is 2, plus a 1 is 3, divided by 2, 3/2 lambda, and so on and so on. Do you understand what I told you about the conditions that must occur or be met in order that constructive interference, loudest sound, versus destructive interference, no sound occur? All right then.